Hello, this is fifth. I think this is a fifth Leetcode session. Uh, Previously, I named them, morning session, night session, but who cares? It's just a Leetcode work session. Sometimes I'm just solving the problems, sometimes I'm just reading write-ups, whatever, who cares? Just getting ready for the FANG interviews. Not just FANG, just any interviews or any algorithmic type of problems. Now let's solve this problem. This is adding using without the add. So yeah, adding given two integers a and b, return the sum of two integers without the operators plus or minus. Well, first of all, let me do some bitwise magic. Let me show some bitwise magic that could implement an add operation. In fact, I'm sure this is how ALU in your computer will do arithmetic. So we need a plus b, where a and b are binary numbers or binary digits. Let's say um, hmm, 1 plus 1. So when we're adding two digits, we could get a result that itself has two digits. So 1 plus 1 is 2, and 2 in binary is 1 and 0. So this case would be 1 plus 1. That would make it the result would be uh, 1 and 0. All right. So we have a, I don't know what this is called. We have a sum digit and we have a carry digit. Sum. To get the sum digit, you essentially have to exclusive OR A and B, because 1 and 1 is going to give you 0. 0 and 0 is also going to give you 0, and 1 will only be gotten if those bits are different from each other. And how about the carry bit? The carry bit is a result of AND operation. It's only 1 if you have it's only 1 if you have 1 and 1. So 1 plus 1, the carry bit will only be 1 if both of them are 1. So how does carry bit let's just take this example, and let's see how the add operation in general works. This is how it works. We start from the right backside. 1 plus 0 is gonna be 1, 0 plus 0, 0, 0 plus 0, 0. This is gonna be 1. This is also gonna be 1. This is gonna be 1. This is also gonna be 1, but here happens an important thing. We have a carry bit that plays a role here. So this is gonna be 1, but carry will also be carried here. Like carry is gonna be carried here. And this bit is gonna be this plus this plus this, which is 2. So we have to write 0 here, and we have to add carry bit here. And 1 plus 1 plus 0 is gonna give you 0 and 1. So we also have a carry bit, I don't know, carry bit here. No, this is how it happens. So, no, this is the result. You add two numbers, you calculate the carry, and then you add it again. Now let's actually try to do this using A and B. We need some kind of a for loop probably, or in fact we need a while. This is important. No. So we have to get another bit pattern, which is carry. It's gonna be 0 at first. It's gonna be 1 at first, or at, and while carry is not null, while we have carry bits, we have to do such thing. So the carry will be calculated like this: a XOR a and b. This is carry, right? But we eventually have to shift it by 1 digit, because the whole purpose of carry is that it adds up to the next digit. So this is now carry. What happens to A and B now? I think A should become well, we have to have an XOR operation with B at some point, right? B. And B will have to become carry, right? Because the carry will have to get added to it. And we use a while loop because once we calculate carry the once and then add it, what's gonna happen is that it's gonna change the carry bit for the next digit. So let me give you an example. Let's just do 1 0, maybe 1 1 1, and 0 0 1 1 1. This is carry. 0 0 0 0, and this is gonna be the result. 0 0 0 0. All right, this adds 2 of these digits, and it's gonna be 0, but the carry, we have carry. What happens here is that we have 1 plus 1 plus 1, which is 3. So we have to write here 1, but we also get a carry bit. No, this is not a good example. Let this be 2. All right. Once we calculate carry bit, the carry pattern once, it's gonna be like this at it's gonna be 0 essentially. This is gonna be 1 plus 1, and then, damn it, how do I say that? Should I do like this? Okay. Now, is this a correct solution? Run. Yes. But why use carry in a while loop? we have to be doing this process over and over again because like one carry addition might cause another carry. Let's say for some reason, let's say we don't know about x, it's just some bits, right? Let's say that this was carry once. So yeah, let's say we calculated this and it was a carry once. We calculated carry the first time and we don't know the bits of b, but we know the bits of a. Now let's say that, all right, this was carried here and then we added here a result and it's 2, but it actually changed the bit here. After this addition, the carry bit has to be recalculated again. I genuinely don't know how to explain this, but know this intuitively. Let me just make some. Oh, here is what you're doing. You are XORing B with A, and then you have to XOR carry with A, which is going to be done in the next loop, in the next iteration. So after you XOR carry with A, it's going to essentially cause you will need another set of carry bits. So you have to do this process until you have the carry bit pattern. Submit this. All right, I don't know how to explain this any other way. Let's work once. Right, now let's do next problem. I'll do the next problem. Given a signed 32-bit integer x, return x with its digits reversed. Reversing x causes the value to go outside of the signed 32 integer range. If reversing x causes the value to go outside of the signed range, then return 0. Still, an environment doesn't allow you to store 64-bit integers. Oh, this is so... What the hell are you gonna do with bitwise operations? I think this is just we can start like this. Let's get environment doesn't allow you to store. Oh, we already did reverse bits. How did we do this? Oh, we used a string. No, we didn't use a string. Let's see. Hmm. So we need 10. We will need 1. No? No, we'll need 10. Then we'll need 100. Then we'll need 1,000. How do we do this? 1. I is less than 32. No, not 32, but 2 to the whatever, like 1,000. Let's just write 10,000 at this point. And then the I++. This is gonna be that. This is gonna represent these numbers. Int last digit, last one digit, x divided by this. Now, no. We need a modulo operator here. A similar doesn't allow you to store whatever. Last digit. Yeah. And let's just see out last digit here. bad. Is bad. Here we are. I think here the main idea is that we get the modulo to get the last digit, and then we use division to like get rid of the zeros. Here I am, broken like a hurricane. How do we append? Like appending to a final result. Let's say we got 3, right? We have to multiply this 3 by 100. We have to multiply it by this, actually. No, not by this, but we have to multiply this by 100 and this by 10. And we have to add it to a result, but the problem is that at the moment of doing those calculations, we don't really know how many digits are in our number, which is the real problem. Which is the new problem. For these, we have to get in a digit, which is going to be which is going to be 10 by divide modulo 10, and we will do the next stuff from 2's, but I equals 2, but we need a while operator. While digit is not 0, and the digit is gonna be updated like this. Or while x, maybe. And return 0, see how it's this. Let's rerun this. Two. Now, shouldn't have submitted. Should not have submitted. Oh, this is bad. This is bad. This is as bad as it gets. Oh, I plus plus. That's what we are doing. I plus plus. Come on, man. 0 and 0. What am I fucking up? Alright, we have the last digit, and then see out the last digit, and then recalculate the last digit. Three, two, three, one. Why that? Damn, this is an easy problem. Why? We're doing for this for 30 minutes. Come on. Let's get 3. This is 3. This is 2, 3, and this is 1. Why the hell is this 2, 3, and this is 1 and not 1, 2, 3? I have zero idea. Did this... I think this... Or should be doing this. God damn it. Alright, alright, alright. We did this right. And then we should get rid of the last digit. Like this, probably. Now this is the last digit. We got 3. with a modulo, and then we should make this no, I think it should be like this. Oh, no, no, no. We don't have to do this. We just need to divide by 10 and then by 10. Like, all right, 3, 2, 1. Finally, damn. Now we have a digit. First digit should be multiplied by 100, the second digit by 10, and the last digit by 1. But the problem is that I do not know how many digits are here. I think this starts by 1, 1, 1, 2, 3. I think I essentially gives four. No, 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 no. I minus 1 gives the... We don't really need I here, so we can set count equals 0, count plus plus, and then we just count. Now, number of digits is 3 here. String Yeah, that's bad. That is bad. Now this doesn't work with negatives, obviously. Here we have to do another thing for char. We have to, all right, first of all, we need to initialize a int result, which is gonna be 0. C2I. I think this will work, right? B times of 10 to the I to the count minus 1, and then we'll set the count and then return res. This is oh, this works for, wow, this is just wild. Now another problem here is how do we, uh, if this number is not enough for the int, we'll have to return 0, I think. But how? This is what I don't get. To string and then reverse, and then string to ll. If org All right, this will work now. I think this will work. Yeah. But we have yet another problem. No, we still have the problem. this issue. How do we make sure that this does not... Ah, all right, hold on. You... Oh, we check if digit is more than 0 and power is more than int max divided by the digit, and power digit is okay and result is more than. Will this work? Do you think this will work? No, this is still an this is still. That was something. That was something.